Hi everyone and welcome back to the series The DSA Multiverse. In previous video we discussed about the binary search algorithm. Now in this video we discuss about the lower bound and upper bound. So without wasting time, let's start our tutorial right now. So first you see what is lower bound. So lower bound is about the smallest index such that it follows conditions because we taking here the array. So array of index, it's always greater equal to the target. If it is satisfy these conditions, it's called the lower bound. So let's take one example. So let's say we have 4, let's say 5, let's say 8, let's say 15 and 19. So this is our array. So you can say that this is our array. And size of the array is basically 0, 1, 2, 3, 4, 5. Let's say this is the 5. If I say the index number, so this is the index number 0, index number 1, 2, 3, and 4. Now, if I'm going to searching here my target, let's say target, let's say 8. So my target 8 is basically these ones because it satisfies these conditions. So my index number is basically this index number. Let's say this is nothing but my value. So 8 is greater equal to my target 8 or not. It means it satisfies the conditions. And you can returning here this index number. Okay? Because it's available. It should be the greater or it should be the equals. So in this case, the answer is equal to index number 2. Now let's say we have a target called, let's say 9. Now in the case of 9, if I check this what, 4 is less, 5 is also less, 8 is also less, and 15 is greater. So 15 is greater or equal to 9. Yes, this satisfies the conditions. Okay, just close to the 9. It's mean that the answer is the 4. I mean, the answer is basically the index number 3 itself. Okay, so it should be the index number 3 because our target answer is basically 15. That's our answer. And answer, I mean, if you need to actually returning here the value, you can returning here this value, or you can also returning here the index number. Okay. Now, what if we have a target called, let's say, the 16? So in this case, our answer is which one is greater than 16 as well as equal. So greater than 16 is nothing but the 19. That's our answers and that's our index. Okay. So if I taking here target, let's say target as a 20. So the 20 is not available. So it may be a hypothetical index. So it may be the 5. That's our index number. So it's nothing but one hypothetical index. We can say that. Okay. So when you don't have any kind of index number, you can assign, you can just give it here one hypothetical index. It's mean the size of the array. The size of the array. So now let's taking here another example and try to solve it using here the brute force methods. Okay. So let's say we have a coding example. Let's say 1, 2, 3, 3. Let's say 4, 7, 8, 9, 9, 9, 11. See, in previous example, we don't have any kind of duplicate. You can see we don't have any duplicate. Now in this case, we have the duplicate. So if I taking here my target as a 9, this is my target. So obviously the smallest, you can see the smallest index. So in here, obviously this 9 should be my index. Okay, this is nothing but my answer because we're looking for the smallest one. Okay, now what if I just go to searching here my index, let's say x is equal to 11. Let's say this is nothing but my targets. So if I am searching for this target, okay, so what I basically do, if I don't want to use the binary search, I can just using here the linear search to try to match one of them. So let's say if it is matched with it, or these 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 or this or this or this, let's match with this number. Okay, then we're returning here the index number of that. So this is basically called the brute force method, or you can say this is nothing but the linear search. It's nothing but the linear search. And if I just traverse the whole array, the time complexity should be the big O of n, because you need to actually searching here the full array. Okay, And after that, we basically getting here our index number. Okay. Now, if it is nothing but the 12, so we may got one hypothetical index, which is nothing but the size of the array itself, because the array index is starting from the 0, right? So this is the thing. Now, how can we optimize this? We can optimize this using the binary search algorithm. And in the case of binary search, the time complexity is basically log 2 base n. Now, why should you can basically use here the binary search? Because you know that binary search is basically used in shorted array. If your array is shorted and follows some kind of the pattern, you can using the binary search algorithm. As well as in the case of binary search, you have the search space, right? Now let's see one example and try to dry run it out, and after that implementing here the lower bound. Okay. So now let's taking some example. Let's say we have 1, let's say 2, let's say 3, let's say 3, let's say 4. We have the 7, let's say 8, let's say 9, let's say 9, let's say 9, and the 11. Now let's give the index number. So let's say this is 0, this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our number of index is from 0 to 11. It means it has the 11 numbers. Okay. So this is nothing but my array. Okay. This is nothing but my array. Now, if I'm going to using the binary search, we need to take care of some of the variables. I mean, with some couple of variables. So let's taking this one as start and this one as an end. Right? Now, in the case of binary search, what we can do actually, we just calculating the meet. So how can you calculate the meet? We can calculate the meet using start position and the end position divided by 2. So in case the start position is 0 and our end position is nothing but the 10. So if I divide it and we getting here the index number 5. So our index number is 5 is nothing but 7 itself, and 7 is basically meet. Now what about our conditions? Our condition is array of index should be the greater than the target. Now for this one, let's taking here x, or you can say target. You can say the target as a 1 because it's quite long, so that you can understand it easily. Just take it to target as ones. Now see, if I see this condition, if I see these conditions, so our array of index is basically 7, and it is also greater than equal to 1. That means satisfy the conditions. It's mean then the greater than number 7, it not be the part of the target itself. We can just trim this out. See, the binary search main motive is to trim down our search space. Okay, we have a left part, we have a right part. We just trim the one part and try to shrink our full array. That's our main motive. Now you can see that this 7, you can see it might be an answer. It might be answer. We don't know that. Is there any kind of value is probably exist? We don't know that. We just think that yes, it might be the answer, or it might be the greater than the targets, because we don't know that if they have the 2, if have the 3, it had the 4. Okay, so taking here this one as my answer, it might be my answer, so you can store it inside a variable. So let's say answer is equal to now the 11. I mean, you're just taking the index number, so you can taking here 10. Now why is 10? Let's assume that we have a target call, let's say 12. So this 12 is not available in this array. So you can taking here one hypothetical index. You can taking here one hypothetical index. So these cases, I can taking here the answer is not even the size of the array itself. The size is basically 10 plus 1. It's mean that 11. So my index number 11 is basically my answers. If you had the value called 12, so that's the maximum answer. It can be the 11, the size of the array. So our size of the array is nothing but the 11s. Now, in here we see that it the greater than the 1, it means you can storing here this index number. You can store this index number. You can store this index number. So you can cross this and you can just store it inside my answers. Now you can just removing this part and we shrink here our array. So what we have, as well as we can also move forward our endpoint to here. to here. So now our arrays look like that. So you have the 1, we have the 2, we have the 3, we have the 3, and we have the 4. So our arrays now look like that. Now, so this is the index number. So let's say 0. We have the 1, we have the 2, we have the 3, and we have the 4. So how you are basically solving any kind of DSA problem, make sure you try it out. Okay. Now, this is our start point. So this is our start point. This is our start point. So this is our end point. Now, if we calculate here the mean, so mean is equal to 0 plus 4 by 2 is equal to 2 itself. It's mean that this 2, this 3 is nothing but my midpoint. So we're checking the condition, let us 3 is greater or equal to 1. Yes, it satisfies the condition. It's mean that the 3 might be an answers. 3 might be an answers. And the index number is 2 itself. Index number is 2 itself. Now you also shrink here our array. We trimmed down our array in these portions. So you have the 1, we have the 2 now. So it should be 0, it nothing but the 1. So now our start is this one and our end is this one. Now if I need to say, if I need to calculate here the mean, so our mean should be the 0 plus 1 divided by 2. So it should be the 0, this index number. Now you see that the 1 is greater or equal to 1. Yes, it satisfies the conditions. It satisfies the conditions. It means that the 1, it can be the answers. It can be the answers. So you can simply go into crossing this out and you can say that this our index numbers. This is our index number. Now you can see that we have to move forward them because we get one number which one is nothing but equal to. Okay. Now in the other cases, what you have, we have the 1. We need to same the shrink down the array, and then we got in here our index number 1. Now index number 1 is nothing but our the start and also the end. Then you have the mean itself. Okay. Now each and time you see that this is our index number, and after that it will just cross this portion. It will look like that. They cross the portions, the start and end. Then our loop is the bracket, and we got in here our answer as nothing but the 0 itself. Okay. Because it is satisfied the condition, now we can shrink here our array. We can say that index equal and equal to mean minus 1, because maybe it also have any kind of indexes. Okay. So in here we got in here our output as a index number 0 that you can see. Now let's take in here another example. I just write it down on here. So now let's say we have 1, 2, 3, 3, the 5, then you have 8, that's 8, then 10, that's a 10, and that's 11. Cool. So this is our array, and our size of the array is basically, you can say that the 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So index, our array size is basically 10 itself in these cases. No? So you have a start, we have our end. So our mean is basically the 0 plus 9 is equal to 4.5. So you can say that 4 is nothing but my mean. So the 5 is basically my mean. Okay. Our condition is array of index is greater or equal to target. Now let's assume that our target is, let's say, 9, which is not available on here. That's our target is basically 9. Now we're checking this out. So our index is basically 5 and is greater or equal to 9. And we see that this is not satisfy our condition. It's not satisfy our conditions. It's mean that our answer is basically the 10. Now it not satisfy the condition. It's mean that the less than 5 are not going to go in our targets. It don't contain any target because our array is shorted. So we can delete this array. We can not delete it, we can trim this array. We can shrink it, right? Now we can just changing our start positions to here. Start position to here. Now our array is look like that. So you have the 8. We have the 8. You have the 10. You have the 10. You have the 11s. Now, if I see the index number, So index number is basically the 5, the 6, the 7, the 8, and the 9. Now in here, start position is this one, and this is our end positions. Now our mid is the 5 plus 9 by 2. So 5 plus 4 equal to 14. So it's nothing but the 7s. Now if I see the 7, it's nothing but the 10. This is our mid. And if I check in this condition, is the 10 is greater or equal to 9? Yeah, is satisfy the condition. It's mean that we can change it in our answers. Now it's mean that which the number is greater than the 10, the number is greater than 10, it not contain it not contain the values. So you can remove this portion. I mean, you can print these portions because we need to have the smallest element, right? So now you can store it inside that. Now our array is also shrink down. Now our arrays look like that, this 8 and the 8. So you have the 5, now you have the 6, we have the 5 and we have the 6. So this is our start, this is our end. So if I calculate the mid, so mid equal to 5 plus 6 by 2. So 11 by 2 is equal to 5.5. That's in 5. It's mean that our 8 index is basically nothing but our mid. So if I see the condition, so it's not satisfy the conditions. It not satisfy the condition. It not satisfy the conditions. It's mean that we need to update it inside answers. So if it is not satisfy the condition, it mean that the lower value is not having the answers. It's not having an answer. Same thing on here. So we can shrink down here our array. We shrink down our array. Same thing. We can say that the lower than the 8, because our target is basically the 8 itself. So the started position is go on here. So it's now right now the 8. So it's basically 6. So 6 our start and end. So 6 plus 6 by 2 is equal to 6 itself. This is also meet. So if I checking this out, 8 is greater or equal to 9 or not, it not satisfy the conditions. Same thing, start will go on here. Start will go on here. And then it will look like that. Okay, it breaks on the loop, right? So this is the main thing behind the scene of the lower bound and upper bound. Now let's try to write down here our code, I mean our pseudocode, and try to implement it. Okay. So let's say the code. Okay, you can say the pseudocode. So we have one function, right? So you can say that the lower bound. So which is taking here an array itself, and you have the target, and you have the size. Okay. So what you can do, you can say the start equal to 0, and you can say that end equal to n minus 1, and our answer is equal to size of the array. Okay. I just take it here and variable for that. It's storing the answers, right? Now we need to creating here a while loop. So while loop start is equal to end, and then we're calculating here the mid. Let's say int mid is equal to start plus end minus start by 2. Now we're checking the condition. Let's say if the array of the mid is greater equal to target, storing here our answer, because it satisfies the conditions, right? It satisfies the condition. We store here our answers, and after that we also let's think that our target is basically 1, and we got in here and mid value of the 5. Okay. So it's mean that we are the less than, I mean the number is greater than 5, it not contain the value, it not be the part of the answers. So you can say that it should be the end is equal to mid minus 1. Okay. Otherwise we can say that start equal to mid plus 1. Okay. So the same thing in here, you can see it's 9 basically. It 9, target is 9. So if it's not containing the value, which one is less than that, because it not satisfies the conditions, it means that we can just say that start plus 1. Because the number less than the 5, it not be the part of the answers. So you can say that start equal to mid plus 1. So this is the lower bound, the simple code, super simple code. Now let's say you implement it out, right? So this is the lower bound that you can see in the geeks for geek. So I can increase the size. Now let's try to implement this out, right? So what I can do, we can say that थोड़ा इधर पे आ जाओ. Okay, so that here int start is equal to 0 and int and equal to should be the array dot size -1. Okay, and then int answer is equal to array dot size itself. Okay, now after that what I can do, you can say that while the start is greater or equal to and then we calculate here the meet itself. Let's say meet and start plus and minus start by 2. Okay, and after that what I can do, we can basically say that if the array of meet is greater or equal to target, then we can store the answer, I mean index number. So 3 is the smallest index in the array 3. You can see we need to returning the index, right? So we can say that the meet itself, and then after that you can say that and equal to meet -1, and then otherwise we can say that the start equal to meet +1. Okay, and finally we are going to returning here the answer itself. Okay, now let's see and try to compile and run and let's see that. Okay, it's passed the test cases. Now we need to go on here and submit it. To submit it in using Python as well. So many test cases it have. You can say problem solved successful, right? Now let's try to solve it using Python 3. Okay, so you have the start equal to 0 and you have the end is equal to array. You can say the length of the array -1, and that answer is equal to length of the array itself. Okay, that's it. Now you can say the while loop, while start is equal to end, and then we calculating here the meet. Okay, we can taking here the meet value because otherwise it maybe give you some kind of error. So you can say that meet equal to 0 itself. Just initialize the value. I don't think that it's not needed. So let's start plus and minus start by 2, and now let's see if the array of the meet is greater equal to target, and then we can simply going to say that answer is equal to meet itself, and then we can simply going to say that the end is equal to meet -1, else we can say that start equal to meet +1. Okay, that's it. You don't have any kind of semicolon, right? Don't be confused. Now let's see and try to run the Python code. Okay, it's compiled successfully. I hope so. Now you can solve it and you can submit it. Yep, you can see that it's submitted. Fine. Now let's see the upper bound. Okay, so let's see the upper bound. Okay, let's see. Now you can see here about the upper bound. So you can say that this is the upper bound. So in the case of upper bound, it's nothing but the smallest index such that the array of the index is just greater, not equal, just greater target. This is the thing. This is the basic difference between the upper bound and the lower bound. Okay, so that's just greater, just absolutely greater. So if I take an examples, so let's say 2, let's say, okay, I write on here. So 2 3, 6, 7. That's 8. That's 8, 11, 11, 11, and the 12. So this is nothing but my array. It's nothing but my array. So this is our index now. Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now our n is basically the 10 itself. Now let's say our target. Let's say target. Let's say 6. Okay. So if target is 6, it's absolutely greater than target. So our target is basically 6. So the number is greater than 6 is basically 7. So 7th is nothing but my answer. So 3, index number 3 is basically my answer. That is absolutely greater. That is absolutely greater. Same thing on here. Same thing on here. Same thing. Let's say if I taking here, it's a target as let's say 8. So absolutely greater. Okay, absolutely greater. That's mean the 8 is basically, you can see this is the, if I taking here the 8. So see 8 is equal. It is equal to this one. That's mean 11 is nothing but my answers. This 11 is basically my answers. Now same thing, if I taking here the 11, if I taking here the 11, it means that the 9 index is nothing but my answers because it's 12. Because it should be the greater, not equal, right? So what is the basic difference between the lower bound and the upper bound? Just it have the, in the case of lower bound, we have the equal sign, but in the case of upper bound, it absolutely caters. Okay. So if I write that in the code in the both side, let's say if the array of the meet is greater equal to target. Okay, so what you can do, we basically store here our index number, let's say meet, and then we have the and is equal to meet minus 1, and otherwise you can say that the meet plus 1. I mean, this is our start. So this is the code for, this is the code for the lower bound. You can say that this is for the lower bound. Now what are the upper bound? The simple, super simple. So if the array of the meet is just greater equal to target, not great, just not equal, just greater target. So you can just same thing, you can store here in the variable, let's say meet. Okay, and then you can say that and is equal to meet minus 1, and otherwise we can say that start is equal to meet plus 1. That's it. That's it. Okay, now let's go in the code and try to implement this out. See, this is a lower bound code. You can just copy this out and can this upper bound, right? So you can go in the Pythons, and here you go, you can pass it out. Okay, you can pass it out, and I'm just removing here this part. Okay, we're just removing here this part. That's it. Now we can compile and run. Now let's see the output. Okay, because the task is pass, we can click on submit. Same thing for Python. Same thing for Python. So the same thing for C++. So C++, we can copy this code. Then you can submit it. So you can say that this is the C++, and you can say the upper bound, and you can pass it on here. Okay, so just removing here this part, and you can now run this out. Okay, so anything wrong here on? I don't think that's wrong. Okay, it's in compilation done. Now you can submit it, right? You can submit it. Super simple. Okay, you can see problem solved. Okay, so this is how the lower bound and upper bound actually work. You can using the lower bound and upper bound to search the positions of the index number, as well as you can also calculate the floor and the ceiling value, right? You can do any of them. First and last occurrence, you can do so many, you can solve so many problems. So why basically solving this problem, the upper bound and the lower bound? Because it just make your thinking capability in terms of the binary search. That's why I try to selecting this topic as well. So that's it for today. Now I hope you enjoy this full tutorial, as well as to share with your friends so that we may get some views as well as the more of student can learn from me. Okay, so namaste and bye bye.